We're going to look at example 7. It says if 2x equals 1/4, what is the value of x plus 1? So this is similar to what we did with the addition property. Before I can solve the second part, I first need to figure out what x is. So I'm solving 2x equals 1/4. So in order to get x by itself, this is 2 times x. The opposite of multiplication is division. So I'm going to divide both sides by 2. And I get x equals 1/4 divided by 2 is the same thing as 1/4 times a half. I'll go ahead and write this. 1/4 divided by 2. Remember, when you're dividing, I could write this as 2 over 1. That's the same thing as 2. When you're dividing fractions, you're multiplying by the reciprocal. That's what division of fractions is. You change the division sign to multiplication, you flip the second fraction. You also can just put this into your calculator, 1/4 divided by 2, and your calculator should give you 1/8 as your answer. So x is 1/8. So now I can go back to x plus 1 and solve this by plugging in 1/8 for x, and 1/8 plus 1 is 1 1/8, or 9/8 if you wrote it as an improper fraction. Example 8 says let blank, then 3r equals 37/2 is true. So we want to figure out what r is. So go ahead and pause this and try and solve for r. Okay, so what you should have done to get r by itself, this is multiplication, we're going to divide both sides by 3. And when you do that division, if you wrote it out, you would have 37/2 divided by 3 over 1, which is 37/2 times 1/3. And then you go ahead and do that multiplication. 37 times 1 is 37, and 2 times 3 is 6. And I'm going to leave that as an improper fraction. Again, there's nothing that divides into 37 and 6 evenly. So let r equal 37/6. Okay, example 9 is going to use that translation that we studied earlier. It says translate to an equation and then solve and check. 3/4 of a number is equal to 6. So earlier we talked about the fact that of means multiplication, is equal to means equals. So I'm going to go ahead and translate this into an equation. 3/4 of, so 3/4 times a number, I don't know what that number is, so I'm going to call it x, you could call it n, is equal to 6. Okay, so now that we've translated it, we're going to solve. So I'm going to go ahead, this is the fraction form, or equation like we did earlier. I have 3/4. To get rid of 3/4, I'm going to multiply by the reciprocal, so I'm going to multiply both sides by 4/3. Over here, the 4's and the 3's cancel. We're just left with x. Over here, I'm going to go ahead and do that cross-canceling that we did earlier. I have a 6 and a 3, and both of those are divisible by 3. So I'm going to divide 3 by 3 and get 1. I'm going to divide 6 by 3 and get 2. And now I can go ahead and do my multiplication. 2 times 4 is 8, and 1 times 1 is 1, so I do not need to write that denominator of 1. So x equals 8. It says check. This is a good thing to do on a test if you're ever worried or you sometimes get nervous on a test. So I'm just going to check my answer, and the way I do that is I go back to my original equation. I'll just write it right here. 3/4 x equals 6, and I'm going to plug in 8 for x and make sure when I do that multiplication it should equal 6. That's what I'm checking. So 3/4 times 8, this is the same thing as 8 over 1. Make this 4 a little bigger. And I'm going to cross cancel before I do that multiplication. 4 goes into 4 once, 4 goes into 8 twice. So I just divided both of those by 4, and now I'm going to multiply. 3 times 2 is 6, and 6 does equal 6, so it checks. We solved it correctly. Okay, the last one says determine whether x plus x equals x is sometimes, always, or never true. So the first thing is, if you can find an example where it doesn't work, you know that it's not always true, and I can right away find an example when it doesn't work. If I let x equal 1, I'm going to get 1 plus 1, and that is not going to equal what I have on the right side over here, which is just 1. So this is an example where it does not work. Okay, so I'll write not true. You can keep going through and you can see that there's lots of examples where it doesn't work. So I know that it's not always true because I found an example where it's not true. The trick is, can I find an example where it is true? So you could keep plugging in values and try and figure that out. Or I could also try and solve. So there's many different ways to solve this equation. You could solve it different than I'm going to show you here. I could do this 3 times and solve it differently each time. So what I'm going to do is I have a plus x here. I'm going to subtract this x from both sides of the equation. And what happens when I do that is this cancels and leaves me with 0, and this also cancels and leaves me with 0, and I get x equals 0. So this is the time when this case works. If x is 0, 0 plus 0 equals 0, then it'll work. So this is sometimes true. And really the only time it's true is when x equals 0, otherwise it's not true.